wasting for you because of you. Okay, so have you gone through the before session? Have you did the assignment? Operators and data types. Have you gone through that difference between W or W and what about Ritesh, Rakib?
Yeah, some I have gone through small.
Okay, Aditi, Vishnu, Suma.
Yes, Prashant. Somehow I just gone through.
Okay, so what is the difference between wire and register data type? Net and register data type.
Yeah, net data type is passing the value, and register data type which stores the value, the bit values.
Which close the value.
Register data type is which stores the bit
Stores the
data.
value. Okay,
Yeah,
store the
bit.
value.
And wire data type it passes the values.
Okay.
Yeah.
Reg data type is used in which cases and wire wire data types are which used in which cases?
Wire data type we'll use when in the structural model.
Okay. Only in structural model. What about remaining? Sagar?
Rich
Yeah.
will be used in always block. Whenever you want to uh, uh, use any variables in always, we put rich.
Okay. Others? Any answers? Okay. Reg and wire data type, you will get the clarity after today's session. Okay. In today's session, we will discuss on description styles of Verilog and the always block, initial block, the continuous assignment statement, procedural assignment statement. So we will discuss about those things today. So you will get the overall clarity, how to use the syntax and what are the rules you need to follow while you are writing the behavioral programming or data flow modeling or gate level modeling. So you will get the overall idea. Okay, so from next onwards, you are able to write any program. Okay, so like how to follow the rules, where we need to put the reg data type and where we do not put the reg or wire data type, how to declare the variables, everything you will get the clarity today. Okay, so I think everyone understood the syntax of Verilog HDL, how to write the module. First, we need to write the name of the module. Then, module, name of the module, port list. We need to mention the port list. Port list means inputs and outputs only, and control signals. Okay, not internal signals. Internal signals means output of one gate to input of another gate. Those are connections, wire connections. Those we will declare with a wire data type. Okay, after that we will declare what are the input, what are the outputs, and we will write the main functionality. If it is a behavioral modeling, we write the behavioral model style using case or if else. If it is a data flow modeling, we will write using the assign statement. So that is what functionality, and last end module. So this is the design structure to write the RTL, to generate the RTL netlist. Okay. So coming to the test bench also we discussed, right? Just writing the module, name of the module test, uh, just a semicolon. Then we need to declare the input and outputs. Okay, with the reg and wire data type. I already asked the question for you. Why do we use reg data type to declare the inputs in test bench? And why do we use wire data type to declare the output in the test bench? If you see here, left side. So here Inputs are I and select, or the inputs. Inputs are declared with a wire data type, rich data type, and output is declared with a wire data type. So we need to follow that rule to write. If we write any test bench in Verilog HDL, we need to follow that rule. Okay. So after today's session, you will get the clarity about that. Okay. And we need to take the instance of DUT, just interfacing the test bench with the design. Okay, how we can interface design and the test bench. We need to do that. And within the initial begin is a procedural block. Okay, I will explain you. And then within the initial block, we need to mention all the inputs and we need to take the values for different inputs. Okay, I equal to 0, 1, 2, 3 based on the combinations. If it is a 3-bit input, we have the 8 number of scenarios. Total 8 number of scenarios we get. 4 input mean 4-bit input mean 16 number of scenarios we will get. 5-bit input mean 32 number of scenarios we get. So like that we need to consider every scenario here. Okay, in the test bench. And next we need to write the display statements. To display the data at the output side, we need to write the display statement or dollar monitor. We can use dollar write. Those things you will get the clarity. Okay. Next end module. This is the simple test bench. So whenever we are writing for multiple designs, you will get the clarity. Okay. So this is how we write the simple test bench and the design. But you didn't know how to write exact structure of the design and what are the rules we need to follow in every style. So you must get the clarity. So today you will get the clarity. So from tomorrow onwards, in the next session, in the Friday session, we will discuss the combinational logic circuit of digital electronics. Okay, we need to discuss in a some advanced level questions in combinational logic circuit regarding the multiplexer, demultiplexer, encoders, decoder, priority encoder, LCD segment display, BCD, and gray code block diagrams. So once we get the clarity on that, Saturday, Sunday, you can work on the digital logic design assignment. Okay. Again on Monday, from Monday onwards, that whole week, we will design the combinational logic circuits in Verilog HDL. Okay. So this is what our next week schedule and this week. Clear, everyone?
Yes.
Others?
Yes, ma'am.
Okay. So do you have any doubts still here? Have you gone through the operators? Ritesh, clear? Any doubts for you?
No, ma'am.
Don't worry, we will discussing the digital electronics also. Okay, parallelly, we will discuss the digital logic block and we write the program for that. Yeah, please tell. Yeah, please tell. Someone called.
Ma'am, I have a small doubt. Like,
Okay.
after this course, when you can eligible for this DFT engineer also, na, ma'am? Like
DFT, we
intern,
will just
in,
discuss internship.
internship
DFT
for
is a
DFT.
different from DV. Both are
Okay.
different.
But
You can try for design verification, RTL design role or verification role.
okay.
Yeah. If you want to go for DFT, I can give you some materials regarding that DFT. Maybe in the month of April or May, we have the DFT sessions also. If anyone started, I can give the access. Okay.
Okay.
Yeah. But as of now, DV only. You need to apply for DV only.
Okay.
Yeah. So
In
how
this, are
many
you
of you
going
gone through?
to, yeah, sorry, Prashanti, interrupting. In this, are you going to discuss the, I mean, something, UVM, something like that?
Yeah. First
Okay.
Verilog, then SystemVerilog, then UVM. But for
Okay.
you, Verilog, then PD, right?
Okay. Yeah, yeah. Yes. Okay. Fine.
Is the screen visible? PPT, everyone?
Yes.
Okay. So have you gone through the operators? Arithmetic operator, relational, equality.
Yeah, yes, ma'am.
Okay, operators we will just put aside. We will discuss one day. Okay, so moving forward, we will discuss on the operator maybe in the next week. Okay, someday. If anyone didn't practice it, just go through the operators. Okay, so once everyone practice, then I will explain again clearly what is the difference between reduction, concatenation, replication, conditional, everything. Okay, so today, as of now, we will discuss the Verilog description styles. Okay, so Verilog description styles in the sense in Verilog HDL we can write the program in four models: behavioral modeling, data flow modeling, gate level modeling, and switch level modeling. Okay, so what is the difference between data flow and behavioral modeling? You already know. Is there any disturbance from my side? Is there any disturbance getting from my side?
Some background noise.
Okay, just a second. Okay, yeah, sorry. So we have our four description styles in Verilog HDL. One is a data flow modeling, behavioral modeling, gate level modeling, and switch level modeling. Okay, mostly we need to follow the rules for data flow modeling and behavioral modeling. Okay, so what is the data flow modeling? Just writing the output expression for the program. Okay, suppose there is a full adder. After writing the truth table, we write the output expression like sum equal to x or bx or c, carry equal to a into b plus b into a plus c into a. We have seen for multiplexer program also. We just need to write the output expression. That is what data flow modeling. Okay, so how we are writing the output expression? Suppose c is the output. C is equal to A plus B. C is equal to A plus B. So we are using the assign here. Assign C is equal to A plus B. So this assign we will call as a continuous assignment statement. Okay. In continuous assignment statement, we need to use assign, which represents the data flow modeling. Okay. Next, coming to the behavioral modeling. In behavioral modeling, we use the truth table. However, we are writing the truth table for any functionality. Same in the truth table, we have number of inputs like A, B or the inputs, and C is the output. 0, 0, 0, 1, 1, 0, 1, 1, and output C for any functionality. Okay, so how do we write the behavioral modeling? We can use either case statement. We already seen case A comma B is equal to 0, 0 means then what is the C? Case A comma B equal to 0, 1, then what is the C? 1, 0, then what is the C? 1, 1, then what is the output of C? Or else we can use the if else statement also, either case or if else. Did you observe what is the difference between case and if else?
Yes, ma'am. I observed case is like a mux it will generate only
Okay.
one mux, and if else means like a sequence of mux 2:1,
Yes.
2:1, 2:1 like that.
Yes. Correct. Did anyone observe? Did anyone observe? What is the difference between case and if else? So case means parallel multiplexer. It always generates a parallel multiplexer. If else means a serial multiplexer. Both are multiplexer only, but case generate parallel multiplexer. If else generate serial multiplexer. Okay, don't worry. In the coming sessions, we are writing the program for combinational circuit, right? Then I will show you one program for case and one program for if else. Meanwhile, if you want to try, you can. Okay, so parallel multiplexer means by using a single multiplexer, all data will be assigned parallelly and we will get one multiplexer. If else means condition. If this multiplexer is executing, then output, or else next multiplexer will be connected like this, or else next multiplexer. So serial connection of multiplexers, if else means. Okay, so that is the different. Another thing is, so for continuous assignment statement, we use assign. But for procedural assignment statement, we use always. Always or initial block. Always or initial. Okay. So what is the main difference between always and initial? What is the difference between always and initial?
Initial only executes only once at the starting of zero time simulation, and always it always means always at the rate of something we will specify the sensitive list, ma'am. Depending on the sensitive list, whenever it changes, it executes continuously.
Okay. So everyone please note down the points. Data flow means assign, which is a continuous assignment statement. So whenever we use assign block, the inputs must be declared with reg or wire data type. Outputs must be declared with wire data type only. Okay, because assign is just a expression mostly used for only combinational logic circuit. It will generate only combinational logic circuit, also called as continuous assignment statement. Continuous assignment statement. Okay, so that's why inputs we can declare either reg or wire, no problem. But output always declared as a wire data type because it doesn't store any data. Okay, whereas reg store the data. Okay, so behavioral modeling. Another thing is assign is a synthesizable. So what is the difference between synthesizable and non-synthesizable? Difference between synthesizable and non-synthesizable. Last session we have discussed what is the difference between synthesizable and non-synthesizable.
Synthesizable means it can be converted to the gate level
Any other
netlist.
answers from others? Lahari, Sumalata, Aditi,
The
Lakshmi.
expression, the RTL code is converted into the equivalent by taking the equivalent logic gates. We used to convert into the by using logic gates.
Okay. Synthesizable means which generate the circuit netlist.
Yes.
Okay. So that is what synthesizable. Non-synthesizable means it doesn't generate any circuit netlist, either it is a block or any gate, whatever, at least a
Yeah,
connection.
like a ROM or RAM and macros like that.
Uh, RAM
It's
or
a non.
ROM.
It's not a synthesizable, right? Macros we are using that directly. It's already predefined, right?
Okay, macros, okay, but mostly in Verilog HDL we don't have any macros, like only just
Okay. Yeah.
include or
Non-synth. I'm telling just example for the
okay.
non-synthesizable. Yeah.
Non-synthesizable means whatever we write in the test bench, all are non-synthesizable constructs only, like initial block, initial block, dollar display, dollar monitor, dollar strobe, dollar time. I have told non-synthesizable data types, right? Reg data type. Reg is both synthesizable and non-synthesizable, but real data type, integer data type, time data type, all these are non-synthesizable. Whatever we write in test bench, maximum all are non-synthesizable. That means it doesn't generate any netlist, any circuit diagram. We cannot do synthesis. Okay.
Yeah.
So in behavioral modeling, we use the procedural assignment statements. Procedural assignment statements. We have two procedural assignment statements in Verilog HDL. Okay. So what are the two procedural assignment statement means? One is a always block. One is a always. Another one is a initial block. First one, please note down because you won't get all points in one page. Like you need to read lot of pages if you want to find out all the points. Okay. So always block and initial block. Always is synthesizable. That means we can write in both design and also test benches. We can write in design and test benches. But initial block is non-synthesizable. That means we can write only in the test bench, which is non-synthesizable. That means it doesn't generate any circuit netlist. Okay. Another thing is when we are writing the procedural assignment statement within a always block or initial block, left hand side variables. Okay, here inputs means, okay, other than input or output, I will tell you here right hand side variables and here left hand side variables. Okay, same here also. Right hand side variables, RHS side variables can be declared with either reg or wire data type, but LHS side variables must be declared with the reg data type only. Okay, so whenever you use always or initial, that means we will write the program, right? So always at the rate of star. I told you star. Why? Because we use the combinational logic circuit. If there are multiple number of inputs, more number of inputs, then we need to mention the star. By default, all the inputs will be mentioned here. Whenever the input, any input changes, automatically it reflects to the case statement. Okay, so without mentioning hundreds of inputs, thousands of inputs, we just put simply star. If there are one or two input, directly we can mention those inputs. Okay, so case, suppose multiplexer, select out is equal to some input of selection, select. Okay, so here this I input is the right hand side variable, select is also right hand side variable. Okay, so these two must be declared with reg or wire data type in the module. Okay, and out is a LHS side variable. Okay, all LHS side variables must be declared with the reg data type. This is the rule you need to follow. Okay, if you don't mention like this, you will get the errors. Same here in data flow modeling also, we are writing assign carry comma sum is equal to A XOR B XOR C. Okay, so A, B, C or RHS side variables you can declare with either reg or wire data type. Okay, but carry comma sum or LHS side variables. Okay, within a assign block, these two are LHS side variables must be declared with a wire data type. Okay, if you write a assign, suppose the same expression I am writing in the always block, we can write like that also. Okay, same expression I am writing within the always block. Then ABC variables can be declared either reg or wire, but carry comma sum must be declared with a reg data type only. Okay, so that's why mostly always block used for sequential logic circuit. Sequential logic circuit. We can use combinational also, but mostly we use for sequential logic circuit. Specifically, if you want to use combinational logic circuit, we use always comb. But in Verilog, we don't have this. System Verilog, we use always comb, always FF, flip-flop. Okay. So that is what system Verilog construct, but no need of now. So did you understood everyone the difference between always block and assign block? Always is synthesizable. We can write in the design and the test bench. Initial is non-synthesizable. Okay. Same initial also same. LHS side variables must be declared with range data type. RHS side variables must be declared with wire data type. Okay. Now can you tell me the answer? I will ask you one question. Okay, so it's a bidirectional shift register. Okay, so in bidirectional shift register, in the design, inputs and outputs are declared. Okay, input clock, select a load, and input a D. Okay, output reg. I already told you in the last session. Here we didn't mention any data type. We didn't mention either wire or reg. Okay, but by default these are wire data type. If we don't mention, by default all those are wire data type. Okay, so here inputs are wire data type. As we are using always block here, okay, left hand side variable is a q. So q must be declared with the reg data type, right? So that's why here output is declared with a reg. If you are using assign in the same block, in the same, here I'm just removing always and just put assign q equal to something d. Okay, so here as I used assign, output no need to declare as a reg. I can simply put here output as a just output. That means by default it's a wire data type. I no need to write like this output wire. If you want to write, you can, but no need. By default, those are wire. Okay. So this is how we can use the assign and declare the variables. And for always block, if we use the always block, especially this LHS side variable must be declared with the reg data type. So that's why we use reg here. Okay. Clear everyone till here? Hello. Fast.
Yes, ma'am.
Yes,
What about others? Aditi,
Yeah.
Yes, ma'am.
Ahmad, Ritesh, are you able to understand?
yes, ma'am.
Please tell. If you have any doubts, you can discuss here itself in the session itself.
Okay, ma'am.
Whatever the doubts you have, I can explain from scratch everything. Any doubts? Rakib, Sagar. Okay, fine. Okay, now my question is, so it's a synthesizable, so always block used here. Okay, and coming to the test bench, in test bench we will write the module, name of the module, and we will declare what are the input, what are the outputs. Okay, so I already told you in every test bench, inputs must be declared with reg data type, outputs must be declared with a var data type. Okay, why it is? So here inputs are declared with reg, output is declared with a wire. We need to follow everywhere same. But in system Verilog we don't have this condition because a lot of confusions will be there here. while declaring the procedural and continuous. So that's why in SystemVerilog we don't have either reg or wire. Directly we will have the logic data type. So that's another concept. But here, why do we declare every input as a reg and every output as a wire? Just observe the code, entire code. Is there any procedural assignment statements in this test bench? In this test bench code?
Always is there, no? Always is procedure.
Okay. Always is there. Any other?
Initial also is there, right?
Initial also there. Okay. Two procedural statements are there. Okay. So why do we declare inputs as a reg and outputs as a wire? What are you observing here within the initial and always?
What? Initial
Within
always?
within the initial and always block, what are you observing? Statements from the statements. Just see that maybe you will get the answer. Just observe how it is written. No idea? Can you read anyone from 8th line? What is happening in this test bench? Ritesh, can you read from 8th line?
Ma'am, in left side there is a register type variable.
Left side there is a register
Right side
variable. Okay.
And in right side, ma'am, no matter whatever we take, like wire or register, no.
Okay. Okay. Others, did you got the clarity?
Yes, ma'am.
So here initial block is a procedural assignment statement. Always block is also procedural assignment statement. According to our rules, always and initial whenever we use, RHS side variable can be either reg or wire. LHS side variable must be reg data type. Okay. So whenever we write the test bench, within the initial block only, we will assign all the inputs. Whatever the inputs are there, every input we will assign some value. So here select is a one input, load is a one input. So we are adding different values. Every time we will assign to input only, that input will be sent to the DUT. DUT will do the functionality and with it will send the output to the console. Okay, at display statement. So here all the inputs are nothing but left hand side variables of the initial block. Left hand side variables of the procedural assignment statement. Okay. So that's why we need to declare all inputs as a rich data type. Even if you see here always block. In the always block we are generating a clock. Okay. Clock is a left hand side variable here. Even clock is written in right hand also, but right hand can be either wire or reg data type. Okay. So left hand side variable is a clock. Okay. Most of the all inputs will be left hand side only, because for left hand side we are assigning the value. Okay. So that's why all LHS side variables must be declared with a reg data type here. That's why all inputs are declared with reg data type here. Okay. Clear till here?
Yes, ma'am.
Any doubts?
No.
Okay, fine. Next, so I think everyone got clarity. What is the difference between procedural assignment statement, continuous assignment statement, right? Next, what is blocking and non-blocking assignment? We will discuss that thing later. Okay. And another thing, if you observe here, we are writing a begin end. Okay, begin end. And here also, left hand side in design also, we are writing begin end. Okay, so why do we write begin and means when there are multiple number of statements, more number of statements within the procedural assignment, there we write the begin end. Okay, so here if you observe always block, in this always block we have only one statement. Okay, so whenever it is one statement, no need to write begin end. If there are multiple, more than two number of statements, at least two number of statements, we need to write the begin end. Okay, so here there are multiple number of statements, that's why we need to put within the begin end statement. Okay, we have begin and fork join. So begin end is the serial execution statement, fork join is a parallel execution statement. That thing you will get in the next week, not next week, and coming sessions. Okay. Okay, I think everyone got clarity what are the rules we need to follow from data flow and behavioral. Okay, and again in the procedural assignment statement, in the always block and initial block, we are assigning multiple values, right, to the outputs or LHS side variables. We are assigning multiple statements. So whenever we are assigning those, we need to check whether blocking assignment or non-blocking assignment. Okay, so that means suppose A is equal to B. That means B value is assigned to A. So in this assignment, whether we need to use a blocking or non-blocking, both are different rules. So non-blocking will be represent like this. Blocking will represent with a just equal to. Okay, both have different rules. We need to discuss that thing. I think you got the clarity. So what is the procedural? Procedural means always initial. Within that we will write the begin end. So non-blocking blocking means within the begin end whatever the statements A equal to B, A equal to 10. So whatever the statements we are writing, we use either blocking or non-blocking. So same flow. Next, same whatever we discussed till now, just a theory part. Okay, so continuous assignment statement which is declared with assign. So what are the rules for LHS side and what are the rules for RHS side? So assign C equal to A plus B, assign Z equal to Y of 10. So how to write the example? Okay, just go through the theory part. And next, here are the different examples how to write the multiplexer. Last time I didn't discuss the multiplexer example, I think, right? Suppose we have written the multiplexer program in behavioral modeling, data flow modeling, and structural modeling we didn't discussed. Gate level modeling also we have written, right, in CMOS also. So whenever suppose 4 by 1 multiplexer is there. In 4 by 1 multiplexer, if you want to write it using behavioral modeling, how many number of statements will be required? At least 10 number of lines. Okay, so case A equal to, selection line equal to 0 0 0 1 1 0 1 1. Like that, a 4 number of statements, main functionality wise I'm talking. If you go with the 16 by 1 multiplexer, 16 number of lines we need to write, 16 number of scenarios we need to write. If you go with 32 by 1 multiplexer, 32 number of lines we need to write. Selection line equal to some 0 0 0 0 0 0 0 1 till 32 number of scenarios we need to write. Like 64-bit, 64 number of scenarios for behavioral. If you go for data flow modeling, even it's a single statement, assign output equal to just a single statement. But whenever the complexity of multiplexer is increasing, suppose that 2 by 1 multiplexer means a very simple statement. 4 by 1 multiplexer we already designed, it also simple. Assign out equal to some s0 into s0 s1 bar into I0 plus s0 bar s1 I1 plus s0 s1 bar I2 s0 s1 I3, like that, a simple expression. But if you go for 16 by 1 multiplexer using data flow modeling, it's a quite um, complex example, complex expression we will get. Maybe we can use either conditional operator, whatever, but still it's a complex expression. If you go with 32 by 1 multiplexer, it's very complex, like that 64 by 1 multiplexer, even we can't write the expression without doing minimization. Okay, if even if we do the minimization, it's a very complex example, like that gate level. So for 4 by 1 multiplexer, nearly 7 to 8 number of gates we have written. Like that 16 by 1 multiplexer, nearly 16 number of gates example, or 32 number of gates. Like that complexity will be more whenever the size of multiplexer is increasing. Okay, so multiplexer is a common, very basic block in every project. Most of the project, the common basic blocks are counters, registers, arithmetic logical units, flip-flops, multiplexer, full adders. These are basic blocks. Okay, in that project level, we don't use a small bit, I mean just a 2 by 1 multiplexer, 4 by 1 multiplexer, we never use. Everything we use in terms of 64-bit or 32-bit, like that. Okay, so whenever we are implementing those type of project, even full adders also, full adders or ripple carry adder, or even registers, counters. Registers always we will deal with the 32-bit size, or 160 I mean 64-bit size, or 120-bit size, like that complexity, more complex sizes. Okay, so whenever the complexity is increasing, the structure is also increasing, the coding style also increasing, number of lines. Okay, so how we can write the simple logical ways, like within a single line of expression, or in even for full adder or multiplexer, demultiplexer, encoder, because these are basic building blocks. Whenever we write these codes in a simple way, then our project will be look very decent. Okay, not very complex. Just for simple blocks, if we write more complex ways, for complex designs like a memory, like FIFO memory, RAM, ROM, for those designs we need to write more complex. Okay, nearly thousands of lines of program we need to write. Okay, so that's why every time for basic building blocks we need to write in an optimized way. Okay, so here are few examples how we can write for multiplexer. Okay, see here, I think everyone understood the concept what I'm going to tell. Clear? Any doubts still here? Hello, are you there? Ritesh, Sagar, Suma, Rakib, Ahmad, and Vinita.
Yes, yes, clear.
Okay, fine. So here how we are designing a multiplexer. Can anyone explain here what exactly happening? Can you explain the functionality here? How simply we have written the code?
If data is a 4-bit and select lines are the 2 bits, assign out equal to data select means if select is 00 means that data 0, whatever data is there, that will assign to out. If select is 01, that the respective data of 0, 1 is assigned to out. The whatever the select is there, that data of that particular select is will display in the out.
Okay. So data is a 3-bit, 4-bit data. So here data 0, data 1, data 2, data 3, all are single bit. Okay, select is a 2-bit. So 0, 0, 0, 1, 1, 0, 1, 1. And output O. So here by using a single expression, we are implementing the multiplexer. Okay. So if selection line is a 0, 0 initially, that means data of 0. So whatever the data of 0, within the data of 0 something 5 is there, that 5 will be assigned here, right? Or else 1 is there, that 1 will be assigned here. If selection line is 0, 1, that means data 1, the data 1 will be assigned to output. If selection line is 1, 0, that means 2, so data of 2 will be assigned at the output. If selection line is 1, 1, data of 3, so will be assigned at the output side. Okay, so can we implement a same logic for 32 by 1 multiplexer, 64 by 1 multiplexer? Same logic. How we can write the
No,
program for 32 by 1?
no. So the selection lines are will get more, right? So it is difficult.
Why it is difficult?
If number of selection lines are more, means the combination also I mean, you get the more number of combinations.
Okay. So how you want to modify the code if I want to write 32 by 1 multiplexer? Same I want to write into 32 by 1 multiplexer. So how we can modify?
Do we need to take another assign statement for select, or assign, or at all at the rate of star we can take? It will check for all the inputs, right?
See, for assign we don't have at the rate of star. For always only
Okay,
we have.
okay. I mean, oh, sorry. Yeah. Sorry.
Assign is just
Okay.
an expression, data flow
Yes,
only.
yes, yes. Yes, yes. Yeah, I got it. Maybe, okay.
So how can I design for 32 by 1 marks or 64 by 1 marks using same example?
Yeah, select lines we can increase now, ma'am. Select lines and data. Simply.
Selection lines and data lines we can increase. Okay.
Yeah.
Is that only enough? Just those changes are enough?
I think it's enough.
Okay. Any other answers from others? Aditi, Vinita, Rakib, Ahmad, Ritesh.
Ma'am, we have to change only select line and data. That's all.
That's all. Okay. Correct. So here, instead of 3 down to 0, it's a 4-bit size. So I'm just putting 31 down to 0. That means data is a 32-bit data now. Selection line 32-bit data means how many number of selection line? 5 number of selection lines will be there. So 4 down to 0. I'm just changing selection line 4 down to 0. Okay. And this statement will be same. No need to change anything here and no need to add extra statement here. Why? Because these inputs, selection line, select signal inputs, we are applying from test bench. In test bench, we need to apply more number of inputs, but in design, we no need to apply any extra statements. Okay. So if selection line is a 0, 0, data of 0 will be assigned to output. If selection line is a 5, that means 5 means 1, 0, 1. So data of 5, whatever the data is there in fifth data of 5, that will be assigned at the output side. So if selection line is a 10, so 1010, then data of 10 will be assigned. If selection line is a 15, that data will be assigned. Like that, if selection line is 30, data of 30 will be assigned. If selection line is 32, data of 32 will be assigned at the output side. Okay, so like that, we will get the combinations. Those inputs we need to write in the test bench. We will do the synthesis of this. Okay, we'll write the test bench, you will get understand. Clear everyone till here? Sumalata?
Yes, yes.
Okay.
The length of the test bench code will be more, right? Then the more
Yeah,
number of inputs it will get.
yeah, we will discuss that also. So how optimized way we can write the test bench, I will tell you.
Okay. Yeah.
So here the code is for 4-bit data, input data, and 2 number of selection lines. So output declare here, assign out equal to data of select. Okay, and coming to the test bench. So module test data and output declared with reg and wire data type. DUT need to interconnect test and DUT. Initial begin dollar monitor statements to display the statements. So initially we are taking data equal to something 1010. Okay, data is fixed, and selection line is changing from 00011011. Okay, 4 number of selection lines. So we'll check the output. See here, data is fixed 1010. Selection line is a 00. Then what is the output? 0. This 0 will be assigned because we have written 3 down to 0. 3 down to 0, 1 down to 0. 3 down to 0 means the first bit will be MSB, third location, and 2, 1, 0th location. Okay. So selection line is a 0, 1. So this 1 will be assigned to the output data of 1. Selection line is 1 0, so data of 2, this 0 bit will be assigned to the 0, and selection line is 1 1, this first bit will be assigned to the output 1. Okay, 4 by 1 multiplexer. Clear everyone?
Yes.
Hello. Okay, so I want to write 32 by 1 multiplexer. So 32 by 1 means here in data input, I'm considering as a 31 down to 0, 32 bit. Okay, so selection lines will be 5 number of selection lines. So 4 down to 0. I'm considering 4 down to 0. So 5 selection lines. Same here also in test bench, we need to write 31 down to 0. Instead of 1, consider 4 down to 0 selection lines. Everything is same, no need to change anything, but in the input we need to write a 32 bit. Okay, so how we write the 32 bit? If you want to write a 32 in a binary, so I need to take 32 tick binary, some 32 number of binary values I need to write, this much of binary values I need to write. Okay, so without writing those many values, I can consider 32 bit hexadecimal. I'm writing in terms of hexadecimal 32H. So how many number of values we can write? Suppose 1, 3, 6, 2. So first 16 bits. First 4 bits, next 8 bits, 12 bits, 16 bits. A also. A means 10 and 5, 2, 4. 32 bit. Simply we can write, or in decimal you can write. Okay, 32 bit data you can assign. Coming to the selection lines. Selection lines is a 5 bit. So every time we need to write 5 bit binary. 0 0 1 0 something. You can come from 0, all zeros, to 0 0 1 0 1 0 to 632 number of lines, selection lines. But it is difficult. We will get more number of values, 32 number of values. We will get 32 number of lines. If you go with 64, we will get 64 number of. Okay, so instead of writing that, we have lot of ways. Okay, we can use a for loop. How can we write the for loop? For integer, I will tell you different ways, but you need to try this one. I'm not going to show. Okay, if you don't get the output, then I will discuss. Input I equal to 0, I is less than 32, I plus plus. So select equal to I. Every time I'm assigning that I value to the selection line. So select value is always changing according to the for loop. Okay, this is one method. Did you note it, everyone? Or else you can take the screenshot. Okay, work on it and let me know if you get the output or not. Okay. Another model is, suppose, okay, before telling that, I will explain you another example. So is it clear, everyone, till here? Everyone clear?
Yes, ma'am, is clear.
Vinita, do you have any doubts?
No, Prasant, it's clear.
Okay, Suma, Ahmad, Ritesh, Sagar, no doubts, right? Okay. So in the combinational logic circuit, the clock is not required. We don't use any clock. Output will be changed with respect to the input. Okay. But in sequential logic circuit, output will be changed with respect to the clock, either positive edge of the clock or negative edge of the clock, and reset. Okay. So in the combinational logic circuit, if you want to apply the inputs, we are applying like this. Okay, data equal to something, selection line equal to something, like the different values we are applying. Okay, but how do we generate the clock for sequential logic circuit? Because clock means we will get like this, 0 1 0 1 0 1 0 1. So how do we generate the clock in sequential logic circuit? It is a running oscillator. Okay, continuously it is running. So how do we generate the clock? I will show you. Okay, so based on that, we need to we can give another style of inputs here. You need to get that answer. Okay, so how to generate the clock? In every sequential logic circuit, we need to write the common logic. So module TB, I'm considering a clock signal as a range. Okay, so no need to connect the DUT because here I am not taking any DUT. So just I am writing initial, begin. Initially, I'm just considering clock equal to 0, initializing clock with a 0. Okay, so like this, initially clock equal to 0. So after 5 time unit delay, so it's a off time, off period. Off period I'm considering as a 5 time unit delay. Okay, after 5 time unit delay, I'm changing, triggering the clock from 0 to 1. Okay, again after 5 time delay, 0, again after 5 time delay, 1, again after 5 time delay, 0, again after 5 time delay, 1. So continuously what happening here? Just a toggle means 1 0 1 0 1 0 1 0 1 0 1 0 means nothing but not operation, not gate. Okay, so continuously it is changing the complementing the value. Complementing means just we can consider as a not operation. Okay, so another thing I forgot to tell, always block is a continuous loop. Note down this point. Always block is a continuous loop. Until we stop the simulation, it never terminate the loop. Whether we can terminate the loop or stop the simulation. Until unless always block never stop the execution. Okay, it's a continuous loop. Initial block is a one time execution. Just it will execute only one time. Until unless you write repeat of something number of times, initial block will execute only one time. Okay, and another thing, within a module we are writing a always block, always initial, like that. Okay, so we can write any number of always blocks within a module. Like that we can write any number of initial blocks within a module. Okay, so all initial blocks, all always blocks will start at a same time, at zero simulation time. Okay, so whatever the delays we are applying in the initial block, suppose hash 0 delay, hash 5 delay, hash 10 delay, based on the delays it start execution. That means it will add the delays to each statement. Okay, so always is a continuous loop, initial is a one time execution. That's why if you observe here in the previous example, initial block we have taken, so initially execute only one time. Okay, it never repeat the number of iterations. Okay, one time execution. Okay, but always is a continuous loop. So that's why here we use the always block to loop these values 0 1 0 1 0 1. All these are continuous loops. Okay, so that's why we use always block to generate this particular cycle. Okay, so I'm writing here initially clock equal to 0, always it's not printing. Always hash 5. I'm just considering as a 5 time unit for every delays. So here 5 time unit, here 5 time unit, like that. Hash 5 clock equal to not clock. That means what? Initially at 0 simulation time clock equal to 0. Next 5 time units clock is equal to not clock, not operation. That means 0 to 1. Okay, again always block. Always block is a repeated block until we terminate. Okay, so again it will go to 0, again 1 0 1 0 1 0 1, like that. It do keep on iterating. Okay, next end module. Suppose simply I'm just writing as an end module here. Like this we can do the clock generation in any sequential logic circuit. Okay, but how can you observe this? I'm doing run here. I'm doing run, but I didn't got any output. Still it is running. Always block is still running because we didn't stop. Automatically do the termination once it reach maximum limit. See, execution interrupted or reached maximum runtime. Okay, so once it reach maximum runtime, it automatically stop the execution. But we no need to waste those many simulations, right? It's not required. So whatever the required simulation time is there, we can do till there only. Okay, we no need to run those because if you go with a complex project, so it takes lot of time to run entire simulation. Okay, so that's why whatever the required time, wherever we want to do the check the output, we just put that simulation time only. Okay, so here I'm writing the another initial begin block and need to check the output dollar monitor and print the clock, because before I didn't print the clock value. And mention the dollar time also to check the time at the output side. And also dollar, okay, dollar finish waveforms I can open later. Okay, at 100 time units I just using dollar finish, that mean automatically do terminate the loop, so it comes out of the loop. See here, 0 simulation time clock equal to 0, 5 simulation time clock equal to 1, 10, 15 till 95, because at 100 time unit I just terminated the loop. So finish the dollar finish called. Okay, we use the dollar finish simulator directive, or also we can call as a system task. Okay, so I want to open the waveform here. I need to check with the waveform. So to open the waveform, we need to dump the file. So we need to use dollar dump file. No need to worry. These things we will discuss one by one in the coming sessions. So just remember the points. Dollar dump file and dump wares. Okay, so now after run, here left side some options are there, right? So here you need to click on open ep wave, open ep wave. Okay, so run option, click on run, so it will open the waveform. See, waveform is open, how clock is generated, initially 0, after 5 time units 1, next 0, next 5 time units 1, 0, 1, 0, 1. So this is how we can generate the clock. Okay, every sequential logic circuit we need to write this logic. Clear everyone? Any doubts till here? Hello?
No, Vasanthi.
No? Okay. So you have asked some question, right? Here we need to write a number of selection lines, 32 number of selection lines, or like 64 number of selection lines. Without using initial block, by using always block also we can write easily. Before I shown you by using the for loop, just a single statement we can generate any number of values. Okay, I will show you with always block also, but by next session you need to get the output of these two. Okay, everyone need to share your output in the group. You can share in the WhatsApp group just output, or you can share me personally, or you can mail to me. Okay, so I will explain how to do that. Selection lines are 5 number of selection lines. Okay, so from 0 to 32. 0 to 32 means 0 0 0 0 0 and 1. These all are zeros. Okay, so again 0 here, again 1 1 1 1 double 0 1 0 1 double 1 0 triple 1 and next 1 4 zeros 8 1 4 zeros 1 0 0 1 again 1 0 1 0. Okay, if you observe properly, here this S0, suppose S fifth one, S5, S4, S3, S2, S1. Okay, so this S0 or S1 is changing for every consecutive repetitions. 0 1 0 1 0 1 0 1 0 1 0 1, like a clock. Whatever the simulation time, it's a 2 simulation delay or 5 or 10, whatever the delay, but it is changing like a clock. 0 1 0 1 0 1, like that. Okay, next S2. S2, how it is changing here? Initially 2 zeros, next 2 ones, next again 2 zeros, and next 2 ones. That means compared to this, suppose if it is changing for every 5 simulation time unit, okay, these 2 zeros, 2 ones, 2 zeros again, that means it is changing every 10 times simulation, 10 units. Okay, 10 simulation time. For every 10 simulation time, it is doing a NOT operation, triggering. Okay, like that. Next, first 4 will be zeros, next 4 will be ones, again next 4 will be zeros, again next 4 will be ones. That means if these are changing 10 times simulation time, next will be change 20 and then 40 and then 80. So this is how we can generate n number of simulation values. Did you got the did you understood everyone what I am telling? That means 32 number of scenarios we can generate by using a 5 always blocks. 64 number of scenarios we can generate by using 6 number of always blocks. Like 8-bit we can generate using 3 number of always blocks. 16-bit we can generate by using 4 number of always blocks. Clear everyone? I will show you by using the clock signal. Same you need to apply for here. Okay, you need to do that and send me by Friday. So initially 5 time units, next 10 time units, selection line is changing. Next 20 time units, select equal to not select. Next 40 time units, next 80 time units. Okay, so here what is the size of clock? 80 time units means so 4 down to 0. So I need to declare the size as a 4 down to 0. Next, any changes? Dollar finish I can take it till 200 simulation time because all the values need to generate, right? So 200 simulation time is also lesser. No, 5, 10, 40, 60. Okay, 200 will be sufficient, or else we can take 300 also. Okay, so now run. Clock equal to not clock. Binary values. Okay, no need to generate the waveform. I'm not generating the waveform, just to check the outputs. Zero to one, always at the rate of 0, 1. Only for first one and last one is printing. Hash. Okay. So clock of 0 to clock of 0, because we are doing the for first bit, and then we are doing the for second bit 1, and here we are doing for third bit, and then here we are doing for fourth bit, and here last final bit. Okay, now run. Same as a selection, but instead of that I took clock. See how many values it is generating, 2 number of times it is generating. Okay, 0 0 0 0 0 0 0 1 0 0 0 1 0 0 0 0 1 1 0 0 1 1 0 0 1 0 1 1 1 0 triple 1 1 triple 0 0 1 double 0 1 1 0 1 0 here, like this. Okay, till 1 3 double 0 double 0 till here, all ones completed, again repeating, because we use the always block, right? Till the termination it will keep on repeating. This is how we can generate the sim within just 5 lines. No need to write 32 number of lines. Okay, clear everyone? All always blocks will start execution at 0 simulation time. All initial blocks start execution at same 0 time unit. According to the delay, the statements will be executed. Okay, and also we have a final block, same as the initial block will execute at start execution at 0 simulation time. Final block will execute at the last simulation time, at final stage. All simulations are completed, then final block will be executed, but mostly we don't use final. Okay, I think everyone got clarity, but you need to do practice, otherwise you don't remember the concepts. Okay, any doubts? Sumalata, Ritesh, Rakib,
No, Prashanti. We'll try.
Vinita. Understood,
Yeah,
everyone?
yes, it is clear.
Yes, ma'am.
Okay. Okay. So you, whenever you get the practice, so you are able to do all these things. Okay. So by practice, you will be getting, you can use for loop, while loop, do while loop, uh, always, initial, forever, for each. There are a lot of constructs out there, Verilog constructs. We discuss one by one. Okay. Okay, then. So you already know the schedule, right? Next Friday, digital logic design, we are going to discuss all combinational logic circuit, and then next week, designing of all combinational logic circuits. Okay. So remember the rules, everyone. Okay, then. Thank you all.
Hello, ma'am.